Hello and welcome to the 17th of our ACCA F5 lecture recaps. This one was on the learning curve. So, what is the learning curve? Well, it's where we have a repetitive process that becomes more efficient over time. Okay, and the reason for this is that employees learn. So they're conducting a repetitive process, they'll become more efficient at it over time because they'll learn how to do it better. It'll occur up to a point and then it'll stop. The reason for that is that no more learning will occur. So at a point, you'll be as efficient as you can be and no more learning can occur. So this will apply where labour is a large part of production, because remember what we're thinking about here is labour costs. Because the labour is becoming more efficient, it'll cost less per unit. It maybe is a new production line, because if it's an old production line, the employees will have learnt everything that they can learn and they won't have a learning effect. And it will have to be relatively complex production. If it's too simple to learn, the learning effect won't be so great. Or it could be for one-off jobs. Okay, so one-off jobs could come in. They're new jobs, something the employees haven't done before. The learning effect will take place. So how do we do the calculations on this? Well, the learning rate, first of all. The learning rate is that the cumulative average time to produce one unit. So what that is the total time divided by the total units. So that's the average time to produce one unit, not the time taken to produce the last unit or the first unit, but the average time to produce all of those units individually. Decreases by a constant percentage. Okay, so that average time will decrease by a constant percentage each time output doubles. Okay, so to understand this, we need to run through an example. The cumulative average time to produce one unit. Remember that I said it's not the time taken to produce one unit or the time taken to produce the last unit. It's the cumulative average time to produce the units that you've made. So in our example here, the time taken to produce one unit was 15 minutes. Okay, but if you look at number 8 units, the total time taken was 91. So the average time taken for one unit is 11.38 minutes. So again, the time has actually come down as you're producing more. There's been a learning effect. Now that's just an example. In our other examples, we'll have a decrease by a constant percentage. So you'll be given a learning rate, for example, 80%. So it decreases by a constant percentage. How do you use that 80%? Well, you'll use it each time output doubles. So looking at this table, if our first unit took 300 minutes to produce, the total time being 300, output is doubled from 1 to 2. Now where we use our 80% is we apply it to the 300. So 300 for the first unit times 80% will be 240, and the 240 is the average time taken for 2 units. So the total time taken will be the 2 units times the 240. The average time per unit will be 240. Again, output doubles from 2 to 4. The learning rate is 80%, so 240 times 80% is 192. Total time taken 768, divided by the 4, 192, the average time per unit. Again, not the time taken for the first unit or the last unit, but the average time taken over all of the units. Okay, so that's what we're talking about with the learning curve. It's the time taken to produce extra units, and that will fall. We can also use our formula. Rather than having to put it into a table like we've just done, we can use a formula. So Y in this formula is the average cost per unit or batch if you're given batches. X is the total number of batches or units. A is the cost of the first batch or unit. And B is our learning factor. How do you calculate the learning factor? Well, you take the log of the learning rate over the log of 2. More accurately, the learning rate is the percentage that you're given. So say in our example 80%, express that as a decimal, so 0.8. Type that into your calculator and press log. divide that by 2 and press log, and that will give you the learning factor. So for example, 80% learning curve, b will equal the log of 0.8 over the log of 2. So practice putting that into your calculator to make sure you can get the right answer. And it should be 0.969 over 0.3010 is minus 0.322. So thinking back to our table that we did above, A was 300, that was the time taken for the first unit. X is 8, that was the total number of units that we produced. B is minus 0.322, which we just worked out. So Y equals A times X to the power of B, and that will get you 154. So make sure that you can type that into your calculator and get the correct answer. 154 is the cumulative average time taken to produce 1 unit that we found in our table above. So using the learning curve, we need to be aware that it's only applicable to direct labour. So you can apply it to labour time or labour cost. It's not applicable to materials. Materials don't learn, so it's only applicable to labour that can learn. It may be used to price one-off jobs. It may be used to set a realistic budget. You may be aware that the learning rate is going to happen, and therefore you can price that into your budget. And it can be used also to get an accurate standard price. Limitations of the learning curve, well, it may not always occur. It may not happen. It will be affected by labour turnover because if you're bringing new employees, they'll have to start learning all over again. It assumes that employees are motivated to learn. If they're not motivated, they won't learn, they won't put in the effort, and your labour time will not come down. Production must be constant because if you're splitting and stopping production, people will forget what they've learnt. And obtaining the data to assess this may be difficult, so do be aware of that. Also, production may change, and if you do change production, you'll go right back to the start again. You'll not be able to apply the learning curve that you have been. And that was our session on the learning curve.